Well, welcome everybody. As always, I hope you're having a fantastic morning, afternoon, evening, night, wherever your either time zone or sleep schedule puts you. We're back after the U.S. holiday last week, and so we'll kind of trying to make the connection and sort of pick things back up where we left off. A couple of notes about the stream. We talked a couple weeks ago about the fact that we're going to do, some. We always start out with a sort of a topic of interest, and as you saw from the title today, I'm going to talk about the Wireshark tool. If any of my students are listening, they should know about it. If they don't, then this will be a time to catch up. But it is a very useful tool, and it will come in handy for some of the things that we're planning to do in various aspects, and so. Seemed like a good time to do that. I'm also planning to talk more about hosting providers. We used a little bit. We played with DigitalOcean a little bit, and because ultimately want to host bits and pieces of things in different places, especially if we want to provide information sources. Those will become handy as well. So we'll do that for the first bit of the stream, and then. PXLip, who's joined me again today, like hopefully most times, will take over and talk about some of the aspects of the local streaming tool we've been working on. And we realized over the course of planning this out that clearly there is more to writing this type of program then every week for an hour or so we tinker with it and eventually the program is done. That's not quite how it works. There's a lot of figuring things out, a lot of trial and error, and a lot of just plain old coding. So I'm happy to say that PXLip has started streaming on his channel. So I'm going to pop a shout out in our chat for him. So every so often, and it's not necessarily on a particular schedule, is it so far?
Not yet. One of these days, I'll figure out what the best schedule is going to be.
Well, if there's
But
a
haven't
schedule, we'll
figured that out yet.
publicize it. Otherwise, follow our Twitter handles. Mine's for linked down below, and your Twitter/PXLip, right?
I say same as my Twitch name.
He's
So
at PXLip.
keep it simple.
Yep, on Twitter. So keep it, follow him there, and you'll. On his streams, and sometimes they'll be short, and sometimes they'll be very long, and sometimes I'll join him by audio on his streams. During those streams, he's going to do some of the nitty-gritty work of actually digging through, how to put the code together, what works, what doesn't work, and so we did that. What was it? Tuesday, this past Tuesday, I think. And tinkering with one of the aspects of the application that has to do with authenticating into the information providers, and so we'll talk more about that and also some of the frameworks later on today. Right. So let me start out. The tool we're going to talk about today is a tool called Wireshark. And if you think that's a weird if you think that is a weird name for a networking tool, when it started out, its name was somewhat less weird, ethereal. But their corporate tagline was "We sniff the glue that holds the internet together." So this weird is sometimes not even begin to describe this, but it is one of the most useful tools that we have in our arsenal for dealing with troubleshooting, diagnostics of the network beyond things like the iPerf tool we talked about. And so before I launch into showing a little bit what this tool does and how it works, let me try to explain a little bit better using our trusty Jamboard here. Let me try to motivate a little bit better what it is we're trying to do. So that tagline with the sniffing the internet glue comes from the term sniffer. Uh, the uh, the original goal of the Wireshark tool, Ethereal, back when it started, was to be able to see what's going on a network. And there are some changes and limitations in how that works today. And so, in order to kind of point that out, I need to do a couple of things here to sort of talk about how this used to work and how this works now, and then we'll kind of go from there. So when these tools were first developed, let's see, that's not what I want. Let's see, yeah, this will work. So when these tools were first developed, networking, local area networks, Ethernet, which is what most of us have, we have wired connections, were a really simplistic wiring scheme. And so when I first started working with Ethernet, the way that worked was we had essentially a long, well, let me make this a little narrower, a long, oh, that's the smallest it wants to get. That's fine. It was originally also very thick, but the wiring was done in a single long coaxial cable. And in order to build your network, any of the devices that we wanted to connect to the network. So if I had a workstation here, I would tap that workstation into this common medium. And there's another workstation over here, and it gets its connection. Initially these were literally tapped into a coaxial cable, and then a little bit later on, this was replaced. So let me see if it'll let me move this. There we go. So we don't want to do this anymore because it's really kind of hard to work with. So instead of doing this, we still use coaxial cable, but what we're going to do is we'll run coaxial cable, put a sort of a T connector here, and go over here, put a T connector here, go over here, and so on. And this was used for quite a while. This was pretty much all of the original production grade. Lots of Ethernet wiring was done this way. And this is the first type of network installed. So we had drawers full of these T connectors and end connectors, because there was sort of a special terminator that goes in each end of this. Now, the point of all this is that Ethernet as a networking tool is designed to have all stations on the network see all transmissions. So it's a shared medium. Anything I send, everybody else can see, and then there's a lot of procedures that I won't go into detail on today that deal with that. So if there's a series of bits coming along here, I will see them. My neighbor will see them, and up. Whoops! What did I just do? There we go. And obviously, like if I send information, it'll go this way, and this person will see it. It will travel this way, and if there's anything else connected here or here, they'll see it. Which, if you have the right tool, makes it really easy to use any one of these stations to diagnose what's going on your network. Because any one station can see all the traffic. And by the way, so if I'm sending this red dashed line of traffic, and this station is not who's supposed to receive that traffic, it'll just ignore it. It'll look at it and say, I don't need that, and it won't do anything else with it. and another station a little bit further down the line, the one that I really meant to talk to, uh, the traffic will go into, and it will do whatever it needs to do to process and maybe reply back to me or whatever. So what I can do is I can use a piece of software called a sniffer and install it, let's say on this computer in the middle, and I have to do one other thing. I have to tell it that don't ignore things. I want to see everything, and I'll get back to that in a bit. That has some implications. So now this guy here, any of the traffic that's running around the network, this guy will see, and at the very least hand to the sniffer. And then I can look at them and decide, is everything working properly? If things are not working properly, why not? That kind of thing. The original, I think the original one of these things, I don't want to highlight or that'll work. We'll do this. The original sniffer software is something called TCP dump. And it's still available on pretty much all Unix machines. I think most Linux distributions have a way to install it. It's a little bit older, but it's still perfectly capable. If all you're trying to do is grab the packets. But ultimately, what I want the sniffer to do is help me as much as possible to decipher what was actually in all of these packets. And that's where Wireshark comes in, because it is really good at doing that. Right? So what we're going to do here in a moment is fire up basically our sniffer that nowadays is Wireshark, and see what's traveling in and out of my machine. Now, before I do that, I'm going to talk about what's different today. Because this is wiring that I work with in the late 1980s and early 1990s. This is not in use anymore. And in fact, fairly quickly into the 90s, we decided what people are looking for is a more robust and more easily maintainable way of installing these connections. Because in the way we were doing this, where's my laser pointer there? So this T connector here is basically sitting underneath somebody's desk, and there's an unlimited supply of tech support stories from those days where the network goes down and we finally track it down and we walk into somebody's cubicle and look under the desk and one side of the T connector is disconnected. And the story is usually, oh yeah, I rearranged my office and I took all the wiring apart and I realized there were two things plugged into this and I think I only need one of them, so I only plugged one back in. Okay. Not so good. So what we really, and also this coaxial cable just was not very very easy to run, not very easy to maintain, easily damaged. It's fairly stiff because it's shielded coaxial cable, so it's it doesn't bend very easily, it doesn't get pulled into conduit very easily. So fairly quickly, what we ended up doing is changing the wiring scheme around. I'm going to do that on this page. Yeah, hopefully I can actually figure out how to do this. So what we actually ended up doing. Give me a. All right. Oh, that's not what I wanted. There we go. So instead of running this cable from station to station to station to station, what I want to do instead is create a central point where I can connect everything usually in a wiring closet, and then I have my workstations here, and here. What I end up doing is I run a set of wires from the central point to each station. Um, so now I have to make sure that all the processes that were expecting that everybody hear everything are still working. And so initially, what the basically the device that was installed in this box was called a hub. And with an Ethernet hub, if there's traffic coming in here, the only thing it would do is make sure that it sent this traffic out everywhere else. So it took a little bit more electronics, but it basically looked exactly like the so we're here. If I send my traffic, kind of goes both ways, and everybody can see it. If I'm here now and send my traffic, it goes into this hub, and it goes out here, it goes out here, and it really works the same way. So it was very easy. We don't do that anymore. We don't use hubs anymore. We use switches. And with the switch, the big difference here is that if I send traffic that I know is supposed to go here, and the switch has already seen both of our devices, so it knows where I am and it knows where the target is, it won't bother sending it on the link in the middle. It'll just send it here. And there's some trickery to make sure that that things don't break, because now the station in the middle, this guy here, actually can't see all of the traffic. But there's some tricks I can use to make sure that it doesn't interfere and that the things still work properly. Now, if you think about it, with a hub, this sniffer concept was still exactly the same. With a switch, if I install the sniffer here, it will no longer see all the traffic on the network, which is something we'll have to, we have to take into account. For a little while, when the switch from hubs to switches first happened, network professionals would actually carry hubs in their tool bags, and they would basically replace the switch or run the parts of the network that they wanted to monitor. They would run them through the hub they carried in that tool bag, so they could actually see all the traffic again. And nowadays, of course, you can't get hubs anymore. They're not certainly aren't fast enough to handle the traffic, even if you still had one from back in the late 90s and whatever. So that's no longer an option. Now, in high-end switches, I can actually tell the switch that I want one of these ports to be a monitoring port. So I can force the switch to kind of act like a hub in a limited sort of way and make sure that even though this red traffic doesn't actually need to go here, it'll still send it. And so that's used in some places in a network to sort of select to say I have a sniffer here and I need to see some of the traffic that's going on. So I'm going to tell the switch to route that traffic, duplicate that traffic out on this what's called a sniffer port. You have to be super careful when you do that, because if there are enough stations here, one of the advantages of a switch is that this traffic here can be running at full gigabit per second or 10 gigabits per second, whatever the speed of the network is. Even if this device in the middle is talking, as long as it's not talking to the other two, if this guy is talking to another device here on the uplink, they can each, the green and the red string, can both be at a gigabit per second. That won't work if you force the switch to duplicate all the traffic onto a single port. So then you have the choice to drop some of the traffic, which you would do if you're monitoring casually and you don't want to disrupt the network, or you force the network to slow down, which you would do if you have to troubleshoot a problem. You really have to see all the traffic. So that's kind of the context that Wireshark exists in today. So when we run Wireshark on a workstation, or really any network connected device. This architecture, the switch-based architecture, is what we're working with, right? And so that means that unless I reconfigure the switch, I'm not going to see all the network traffic. So a lot of times today, unless we're running Wireshark on a monitor port inside the network, which a lot of organizations will do selectively and carefully. For the most part, what we are going to use Wireshark for in downstream, and what is to look at what our own applications on our own computer are doing, right? So having Wireshark installed on my workstation here means that I will see all the traffic going in and out of this workstation, which a lot of times is what I need, right? And so when we fire up LST and we're trying to figure out is it really talking to Twitch, is it really talking to Streamlabs? This will give us some indications of what is going on the network. And I'll get back to that point in a minute, because there are also a couple of other things we can. There's one other thing that we will need to do that Wireshark will also do for us. So in some sense, this switched environment, people sometimes think about as being more secure. Because I'm not, any given station can't sort of surreptitiously grab all the network traffic and look at it. That isn't as secure as it might sound, because if I'm over here and this is not configured as a sniffer port, normally this station here shouldn't see my traffic. If there's a bad actor over here, what I can do is I can on purpose. What do I not use? I'll use this. I can on purpose pretend to be a very large number of devices all hanging off on this port. I basically send random stuff that looks like there's 100 devices hanging off of here. This switch only has a limited amount of storage to keep track of what device is where. And so if that storage fills up, it'll just forget devices that it used to know about, but it needs to get rid of them so it can store the new stuff that it thinks is relevant. So if I do that, then for at least some brief periods of time, because the switch now doesn't know where the target, for example, my traffic is, it'll send the traffic to both places. So obviously switches will try to protect themselves. I can certainly configure a really good modern high-end switch and say, hey, don't accept more than 3, 5, 10 devices on a single port, that sort of thing. But there are all sorts of tricks I can play to defeat this. So the point of that is, from a security perspective, don't assume that because you're in a switch, somebody with a sniffer on another port can't see you. There are ways to make that happen. The other thing that always shows up, and we might see that, I don't know that we will. The other stuff that always shows up is broadcast and multicast traffic. Right? So if a device sends traffic that is supposed to go to more than one destination, even though it's not everyone, that's called a multicast, and if it's supposed to go to everyone, it's called a broadcast. Most switches, at least the sort of moderately priced ones, have no way of knowing where this traffic is supposed to go. So that will become traffic that goes everywhere as well. So we will normally, when we run a sniffer, we will normally end up seeing traffic from. We will see everybody's broadcast traffic. We will see everybody's multicast traffic, and then we'll see sort of odds and ends. One thing I'm going to ignore today, because for time reasons, it gets a lot more complicated when we start talking about wireless networks, Wi-Fi. Because the Wi-Fi protocol is a bit different, the hardware is a bit different. That's sort of a separate topic, and that I may pick up at some other time. But that gets a little bit beyond what I want to do today. Right. So let's see what we get when we actually fire this up. So I'm going to clear you out of here, and I'm going to start Wireshark. And there's so the first thing we're going to have to do, and I do not know if this guy will let me. No, I can't make that any bigger. That's unfortunate. Oh, maybe I can. Nope. On this screen, I can't. I can on the next one. So it's going to be a little bit hard to see, but the initial screen on Wireshark, well, it basically presents me with a list and saying, there are lots of network connections. Which one would you like me to use? And you look at it and go, wait, I'm a computer. It's plugged into a network. What do you mean there are 8 or 9 or 10? Now, this is actually very window-ish, and if you have any thought, if you have any experience with it, let me know. But I'll try to explain as best I can. So part of what's going on here is that a lot of computers will actually legitimately have more than one network connection. They may not be active at the same time. And then Windows, on top of everything else, does something really weird that I don't entirely understand. So let me bring up. So this is just basically a PowerShell command line. And so one of the more useful things I can do is a command called ipconfig. And it will happily show me all of the network connections that Windows thinks exist.
Yeah, I remember when it first started returning all of the virtual network adapters.
Yeah, and it's not entirely clear what I'm still trying to track down what some of these are. So in this case, so you can see there is a long list of adapters here. So Wireshark isn't wrong. It really is seeing a whole bunch of adapters. So this first one here is real. That is my wired connection. I have an address, and I have routes. So I'll show you another display in a second. And this is actually an active interface. I do have a Wi-Fi card in this computer. Even though it's a desktop, it does have a Wi-Fi connection. It's just not set up. In fact, I disabled it because I don't need it right this minute. So it is legitimate, but it is not active. Then Windows, for some reason, decided to create 2 virtual interfaces also connected to the Wi-Fi. I don't know why they're there. I don't know what they're supposed to do. And they seem to change every time I look. They're different. And then there is I have a Bluetooth adapter, a Bluetooth card in this PC as well, and so technically you can use Bluetooth to connect to another device that has internet connectivity and run internet over Bluetooth. It's one way, for example, of using your phone as a hotspot. You can do most of the time we do it over Wi-Fi, but you don't have to. You can do it over Bluetooth. Like with the devices like the iPhone, that's one of the options. You can choose Bluetooth or you can choose wireless. So they're legitimately one of the other ways in which you can get information on this, and I won't get into a lot of this today, but it's something I might explore in a future stream. So there's a subsystem in PowerShell that that lets you retrieve information about different aspects of the network configuration. And so, for example, net adapters will list the real ones. As you can see, I have an Ethernet connection that is shown as being active. Good thing. And it's a gigabit. It's a gigabit link. The Bluetooth connection, I don't know why it shows a speed there because it's not actually connected. That doesn't make a whole lot of sense. And because Wi-Fi is disconnected, it doesn't show a speed either. Let's see. There's a couple other things that are kind of fun to do here. Nice thing about PowerShell is you can just kind of start with a subsystem. So I think I want to go to IP. And so this is kind of this gets kind of wild. These are all the IP addresses, and there there are IPv6 localized addresses on each of the virtual interfaces, which is not super useful. But oh, I know what's going on here. Ha ha. Yes. Okay, that makes more sense all of a sudden. This is what's going on. Some of these links are links that have are addresses are associated with addresses that have timed out. That's an IPv6 ism, and so some of these things get created and then replaced because IPv6 updates its addresses for privacy reasons. So this is we can do this. What was the other one? Yeah, so this is another view that gives us a better idea of what's actually here. And so when we ask about IP configuration, we're now only getting interfaces that are actually real, as opposed to the deprecated ones or the disabled ones. So in reality, then there really are only two. There's really only one interface, the Ethernet interface, that we should be doing anything with one exception. That's why I brought the other one up. This one here is actually going to be sort of important for us. Every network device has something called a loopback interface. And in IPv4, it has the address 127.0.0.1. There's an equivalent one. I think it's ::1 for IPv6. This is used for applications within the same computer to talk to each other as if they were talking over a network. And so we are building a connection between the LST application and OBS using WebSockets, and there's no reason to go out onto the network and back in. That would be silly, right? So that connection will happen over loopback, right? And so when we go back to Wireshark now, and again, it's hard to see. I apologize. But I think what you can see, even if you can't read the text, is that there are two lines that show this one here and this one here that show activity, because Wireshark is sort of kind enough to identify sort of which ones are active. One of these is Ethernet. The other one is that loopback adapter. All right, so I'm going to. So what I'm going to do now is I'm going to let this thing grab just a couple of seconds of traffic, and then we'll take a look at it very briefly. We'll get back to this as we use this tool to diagnose some things. I want next week. I'll probably talk about what you can and cannot see when you look at a secured web connection, for example. So let's go to our real interface, wired interfaces. I want to go to Ethernet. I don't want to filter it. And I'm going to start capturing packets. And so we have about 7,000, 8,000, 9,000, 10,000 packets, good enough. All right, so notice that things were flying by pretty quick, right? So, I think we captured what? I didn't keep track. It felt like what? 3, 4, 5 seconds, maybe.
Oh,
A few
feels about
seconds.
right. Yeah, a few seconds.
So now hold on. Before I do anything else, let me do this. Oh, now I've got to get some things organized here.
Yeah, you might have to go up even a couple more.
I think I need to make it a bit bigger. Still? Yeah, maybe.
Yeah, 1 or 2.
Let's try that.
Yeah, that looks good.
Right. So, I need to move this one a little bit. So in those few seconds, we grabbed, looks like 13,023 packets. So there's, there's a couple of things we can do. The nice thing is I'm going to just pick on something here early on to see if I recognize anything. Right, so this would be web traffic. This is so we'll get back to that. But one of the things I wanted to point out here. So I randomly picked a packet here that like the 6th one we captured. 10.0.0.3 is me. That's my computer.
I forgot to use the 10.0.
Yep. It was talking to a computer at 162.159.136.234. And this is a secured web connection. The protocol here is TLS, which is Transport Layer Security. So the nice thing is, Wireshark is not just a sniffer, meaning it doesn't just grab the packets off the network. It will also give me a ton of information about the content of the packet. So there's a section here that lets me figure out Ethernet, and it's kindly enough to tell me that the packet came from my router, which is Ubiquiti router, for example. So this is the network layer, the local area network layer. Here's here's all the detail about. Let's see, I'm going to do this. We're going to kind of move down the. There's a section that actually shows the raw data. I'm going to move that kind of out of the way. So this is all the information about networking. What were source and destination addresses, a whole bunch of other stuff about the network, the network transmission itself. This is the transport part. So this is TCP. And again, I'm not going to go into any of the details, but you can see there's a ton of stuff here that I can figure out. And if this was an unsecured packet, I could now actually go and look at the data being sent. Because this is an HTTPS, one of the secured web connections, everything below here is encrypted. So there's basically an indication here that I'm looking at HTTP over TLS, which is HTTPS, um, and I'm only seeing the encrypted data. Now there are ways for me to tell Wireshark if I have it. I can tell Wireshark what the key was, and it will actually decode it. And so we might do that at some point if necessary. Good news here is if we have our application talking to Twitch, we can see if there's traffic going back and forth if the connection gets established. I cannot see what's in it, which is also a good thing because when we talk about the authentication and there are. Oh, hi ODG, welcome. Can you do the shout out for me?
That's doing it now.
Awesome. Welcome.
Cheers. Yeah, say welcome.
Great to have you as always. We're just finishing up looking at the Wireshark networking tool. So we're gonna switch. We switch over to talking about the LST tool. We're going to talk about how we actually get basically an access key to be able to be allowed to go into Twitch and retrieve information, for example. And so obviously we don't want those keys flying around in clear text.
Little things.
This is one of the ways in which we make sure we prevent that from happening. Again, and now I need to look at it. This has changed a lot since I've last tried to do this. I need to try to figure out how you exactly do that. But obviously, my browser knows what the decryption key is. So if I extract that key and put it into Wireshark, Wireshark will then tell me what was in this packet. So if I can figure out how to do that, we'll play with that in a future stream. What I wanted to do, I think. See, it started here. Tell me you can increase this, otherwise it's not going to make a whole lot of sense. Nope. That's not useful. All right, so yeah, I'm going to have to find a better way to capture this and then make it bigger. Unfortunately, they don't. The Wireshark isn't great at doing these things. So
it's a little bit of an old application.
Yeah.
Still learning.
So the what this tells us is that we have a number of and so I don't know if anybody can see this on the screen or not. Let me make this as big as I can. Now that's not going to work because it doesn't make anything bigger. It just makes the window bigger.
Yeah, and most of it's under my head now. So.
Yeah, I just moved it. So what this will tell us is that we have a lot of TCP connections, which we'd expect. I've got lots of connections open to various places. We also have lots of UDP traffic, and of course, we would expect that.
It's my fault.
Because we have a lot of streaming stuff going and real time stuff going on. So that one is useful. I can so the conversations are really the bit that makes the most sense here. And if I kind of pull this down a little bit, one thing I can do is I can, for example, put in a filter and ask just for UDP traffic. And I'm doing this just to sort of show that there is just a lot of it here. And UDP, of course, we talked about that several weeks ago. UDP, of course, is the sort of preferred way of sending like one blast of data at a time send real time information. So we used iPerf to do some load testing with UDP. I wonder if I'm not sure. Is RTP? Yeah, I don't know if there's RTP traffic in here or not. There is not, which is interesting. So we're using RTMP traffic, I think. Nope. I thought I saw RTMP in there. Oh, I need to do that first. Nope. Could have sworn I'd seen an RTMP. There it is. Real-time messaging protocol. So that I think is part of what's going on. I think this is part of what's going on in our streaming world here. So there's lots of stuff we can do to try to figure out. So I can, for example, I can. I can try to do that. Notice that what I just did is
Will it DNS look up all the
Yep.
IP addresses? Is that what just happened?
Yep,
That's
that's
cool.
what just happened. And so this real-time messaging protocol is going to Twitch.
Yep.
That
makes sense.
Yeah,
ODG was asking about that. He was expecting to see Twitch streams, but yeah, there it is. There it's all on the RTMP
yeah, that
streams.
it's there. So that's so RTMP is definitely a piece of that. And
Wait, is it? ODG asks is pointing out it's still Justin.tv, which is a major throwback
oh yeah,
to the
I don't.
origins of Twitch.
They have. I don't think they've. I think they
Justin
still
hasn't
use that
existed
domain.
in 5 years. I think they shut down Justin.
Yeah, it's kind of interesting, isn't
a while
it?
ago.
They
That's
still
hilarious.
use that. This I'm pretty sure is PXLib.
What am I? Pool 71? Is that the one you're looking at?
Yeah.
Yeah, who knows? It's gonna be a manually assigned or an assigned IP address from.
Yeah, it would be the outside of your router. Is that yours? Your IP address?
It seems like a safe bet, but
I suspect it is. So I think so.
Hang on a second.
So I'm just just to kind of wrap up this part.
Yeah, that's me.
Yep. So we are actually talking directly to each other over UDP, which we expected.
We thought we were. We played around with that a while ago and we got thrown off initially, but yeah, that was what we expected.
So obviously, if I'm going to let's see. Yeah, ODG said only really use Wireshark for load monitoring. Yeah, I've done quite a bit of that, but it's also quite useful to look at very, very much the details of what goes back and forth between stuff. Yes, it is still and yes, it is still called Justin TV, which is really funny. Yes. Something with the performance we get. I suspect the ones called Justin are still the same hardware from several years ago. Yeah, that might also be the case. So the point today was just sort of to talk about what this tool is capable of doing, and you notice that I can do this. I could do the same thing on the local loopback interface, which means that when PXLib and I have LST running, talking to OBS, I should be able to watch that interchange going back and forth. And that's a question for you. Are WebSockets automatically encrypted?
That's an excellent question. They should be automatically encrypted, but I do not know off the top of my head.
So if they're not, we can actually look at the details of what we're sending back and forth. Otherwise, we'll have to be a little bit more. We have to work a little harder.
Yeah, I'm guessing that they are automatically encrypted, but that's like I said, I'd have to check the standards.
Yeah. Uh, so ODG says I've grabbed hex packets from Wireshark and decode them back to the C structures once we were
Jesus.
having some signing issues with the signing servers. I would imagine you nearly went blind. Yeah. So what? I'm curious. What forced you to actually have to? Hopefully you were at least able to work from, something like this where all the data is already broken down for you. But if you had to work from the actual hex data down here, that would be really painful.
That admittedly sounds really unpleasant.
And Wireshark, one of the things that is really cool about Wireshark is that it each update that they put out, they add more and more decoders. Right? So the delay tolerant networking software I've worked with for almost a decade now. There's a decoder in here for the current version, not the version that was just released, but the version has been in effect for several years now. There is a decoder in here that can handle. And actually, one of my students wrote one piece of that decoder for the security part of the protocol. So there are lots of people contributing to Wireshark, and so in many cases, we won't have to go blind trying to go through the hex code, the hex down here and decode it.
I hope not.
Generally, I can go in here and get at least to a point where I understand all the interchanges that happen. Now this looks like it's raw. This is raw data. So that I'm really kind of surprised that they're not using RTP. So this one we would actually have to decode by hand. Certain signings were failing turnovers when the keys were being sent at a couple sets of bytes in certain order. Yeah, expect there was an overflow, underflow when they're breaking them down at their end on the yeah. If you have to work, that makes good sense. If you have to work in the actual payload data that's not part of the network protocol, then Wireshark won't help, right? Because it doesn't nobody's built a decoder for it. And you have to do exactly what you said you said you had to do. Yeah, that's painful. I'm kind of curious to see what we're doing with these guys here. Real-time messaging protocol. Yep, we're just, I don't know, they're just sending stuff. This is a protocol I don't know a ton about yet. So once I do, I'll definitely feature it on stream. We'll go through how to actually work with this, but I don't know a ton about it. So I think I've actually gone a bit longer about this than I intended to, but I think it was okay. But at this point, I'm going to shut this down and let PX Lip take over, and we're going to talk about a couple of bits and pieces that are coming together for the LST application. So let me shut this down. I don't need to save it. And then I'm going to switch over to. You have your screen ready to be shared?
I do. Hopefully the fonts are big enough this time around. Never know. Nope. So I think we had mentioned last time that we were sort of worthwhile going through sort of the process that I had followed to sort of get this application sort of off the ground, the scaffolding of it. Uh, part of the fun is getting distracted, ODG. So part of the fun is all the tangents we get to go off on. Um, so I thought I would just sort of walk through the steps that I took to get a really bare bones Electron application that is running Vue as its front end renderer, front end framework. So I there are other ways of doing this. Don't let me tell you otherwise. Yeoman and a million other ways. There are starters up the wazoo, but I personally like sticking to sort of the officially supported method. So we're gonna just go. So I I've already installed the Vue CLI, so it's pull it up here and tell you. So it's at Vue/CLI, installs a little binary on your system, so then you get a Vue command. So I can now Vue create. I'll call this demo app. And so this is going to give me some options eventually, hopefully, maybe someday. There we go. So this is your presets, and I played around with different ways. So you can see that Vue 3, do I want TypeScript? What extra pieces do I want installed on there? So we'll just stick to the default for now with Vue 3 preview, just because Vue 3 is sort of neater.
Yeah, ODG, I noticed that too. Picks up so your terminal window looks okay, but something is scaling your VS Code window in a way that
Interesting.
makes it very blurry.
Interesting.
Um,
Okay, I'll have to play with that because I'm not sure why that would be happening.
I think ODG is right. Something's either being up or downscaled in a weird way, and
Yeah, it
it's
must
breaking
be
it's not scaling the font properly. It's actually trying to pixel scale up or down. I think we're so
interesting.
it's a good bit blurry for some
I don't
reason.
know if that helps or not, but oh
Yeah,
yeah, it really is.
it helps a little bit, but just I guess we'll have
I think
to play with that
yep.
profile setting that
I
we were
think
talking about, and
well,
just come up with a different font setup for the
yeah,
tool.
I think too. I probably should look at what I'm outputting to you because right now it's just the full screen, and so that may very well be getting scaled in the process of getting sent to you.
Yes,
I just don't know how
that's
to
very
handle that yet.
possible. Yeah.
We'll figure it out. That'll be fun. Yeah, except I'm not actually outputting through OBS. I'm just using a WebRTC client essentially to send my screen directly, and then the yeah, it's just grabbing the whole screen, sending it over WebRTC. So we'll figure it out.
Yeah,
We'll do that off stream at some point.
but of course, ODG, you're right. It's coming into my OBS as a web source, and there's a very good chance that my OBS is doing some scaling on it.
Yeah,
So before the next stream,
we'll
we'll run some tests and
we'll
figure
get that
out.
figured out.
It may be my OBS settings doing the scaling on you.
Yeah.
But anyway,
Well,
back to
yep.
where we were going to
We
be.
were. Fortunately, I'm on the left right now, and in
Right,
fact, I can do
that one is pretty
that. So,
readable.
yeah, so that can help a little bit. So I'll actually walk through sort of just all the features really fast. So um, we're actually going to turn that off. So I can choose. So right now there's not a significant, but there's enough of an API difference with Vue 2 versus Vue 3 that they're giving the option of which one to choose. Babel is essentially required. Babel, we talked about this, I think, a couple of weeks back. Babel is the transpiler. It lets me use the most recent JavaScript features that may or may not be supported by a given browser or a given node
All right, yeah,
environment.
yeah.
Obviously, TypeScript is TypeScript. It's a Microsoft supported superset of JavaScript, which provides some enhanced language features. They are quite powerful. I tend not to use it because I tend to forget to write the TypeScript code. So one of these days I'll force myself around it. But it introduces things like interfaces and typed variables, things like that. So it is really quite powerful. The Vue router is basically a way to handle a single SPA, single page application. So, all those websites that you never really navigate between pages. There's no full round trip to the server and back. It just gets some new data and re-renders the page. So the Vue router allows you to have updated URLs. Otherwise, you'd have an SPA where the URL never changes, but you navigate through it, and that's really bad. Vuex is in larger applications when you start dealing with lots of data. You don't want everything to sort of every component to be managing its or page for that matter to be managing its own data. So this is to have a centralized data store that is essentially your single source of truth. CSS preprocessors. I don't think we've talked about CSS, but that's the style language of the web. Um, it is it's essentially the way we make websites look good. that's at its really bare
Hmm.
bones. But CSS in and of itself, sort of like HTML or JavaScript, stagnated for a while. Now it's getting better, in a good way. Like there's good grouping around it. But the preprocessors, there are a number of essentially, again, supersets around CSS, Sass, and less, and there's another one I can't think of off the top of my head, but they're basically compiled versions of CSS that eventually will output pure CSS, but gives you some extra functionality, loops, and different tools like that. Linters and formatters, huge thing in my opinion. Basically, you're guaranteeing everybody who uses everybody who edits in your code base, the code that comes out of it looks exactly the same every single time, which is really quite important because, remember the old days of tabs versus spaces, and is it two spaces or four, and do you want semicolons at the end of lines, which is an option in JavaScript, which we shall not mention. Um, Things like that. So this way, you basically, there's a post-processing step that makes sure that every JavaScript file in your project, or HTML file for that matter, matches a set of rules, so that when I edit it, there's no additional cognitive load around, wait, am I tabs or spaces or semicolons or not, or trailing commas, that sort of thing. And then the last two are unit and end-to-end testing. That's just sort of added testing functionality. We won't play with those right now because that's a whole nother stream.
Oh yes.
So we'll go through this. I'm going to pick 3.x. I'm not using history mode because I'm going to be in a web application. We're going to use Dart Sass. So I personally, I like SCSS. It's pretty simplistic, just adds some nice, interesting functionality. Um, ODG says easier than having a company coding standard Word document that is 150 pages long. Yeah, there's the beautiful thing of all of these automated processes, and like I'll have I don't know, a 20, 30 line sort of override of the accepted standard. Not even 20. Honestly, I think I only override like half a dozen rules, and then everything just gets output in the correct format. Um, Speaking of, I prefer Prettier. Prettier sort of becoming one of the main ones. It's a
Is
little bit
is
more
that is that is
opinionated.
that Airbnb as in the
The
Airbnb
Airbnb,
company?
yes, they
They
put out a
wrote their own
lot of
standard. There, ODG,
no, they
there's your the
yeah,
replacement reward
essentially.
document.
Yeah. So what they did is ESLint is the sort of accepted standard for making sure that your JavaScript looks right, and not just from a formatting standpoint, but from a this is legal or not legal JavaScript. What Airbnb did is they put out a set of additional, like a set of rules that or a set of applications of the ESLint rules that are specific to their company, and it took off. A lot of people found it to be a really good base configuration that they would often iterate upon. But yes, it is very funny. Airbnb put it out. I mean, Google has their own standard. Facebook
Right.
has one. Everybody's got one. It's just Airbnb kind of, for some reason or another, became the big one. But Prettier is my personal favorite. And yes, so lint on save basically says it'll yell at me whenever I save a file. Lint and fix on commit, when I commit to the GitHub repository, it will actually change the source file so that it matches the standard, or do its best. It will avoid doing anything that could be a breaking change. And then this is opinionated. I like dedicated config files. We are not going to say this preset because I will. And then so the last one I jumped to really fast. It asked, did I want to use Yarn or NPM? Um,
Those are
Yarn,
package managers, right?
yes, they're both package managers. Yarn was put out, I believe it's a Facebook product again. And I think it was because, they have really big JavaScript libraries. And so an NPM install so you're sitting here watching it do its thing, can be longer. And Yarn's goal was to sort of speed that up and be a little bit more um, predictable. NPM had some issues with, two different environments and the predictability. Um, uh, so Yarn came out, NPM then sort of followed suit, realized where their flaws were. So NPM has essentially caught up with Yarn in a lot of ways. ODG says, I just wish they would line up braces. Always hated scanning code with braces not lined up. Yeah, the formatters do that. It's part of why I require them on all the projects I spin up, because otherwise, yeah, no, trying to scan code with braces, one set of braces, three indents in, and one set four, and no, just no. So uh, now the only downside is that you guys are saying this is a little bit. Um, nope. Folder. Sorry, hang on a second. There it is. Okay, so there we go. That is what was spun up. So this is your really bare bones. This right now is purely a front end browser based application. It doesn't have a back end. You would be expected to hook something up, either running your own server or an API gateway or something like that. Um, So to take it, to sort of take it and make it an Electron application, what we're going to do is, and I meant to look,
Before
yeah,
you go there, so you said you just said this is a browser-based application. So
mm-hmm,
there's something that you could technically
mm-hmm,
run in a browser,
yep.
and it would create like a web page or something that just doesn't do anything,
Hang on
essentially.
a second.
Oh,
This will
and
take a second.
we're running a local
Yep,
Node.js server.
yep. And if I, nope, I was like, I can't remember if, and I think I'm running something on 8080 right now, so otherwise it would use, there you go. So the, the pre-built um, Vue application.
Vue.js app,
Yep.
and so it's being served
From
through
a,
from your local directory, but
yep,
through a web server that's
yes,
running locally, which is why but it was one of the reasons I pointed out the loopback interface, which is just running on
yes,
loopback, and
yep,
we could
localhost.
in theory see that.
Yeah, you can't quite, probably can't quite read it, but this is on localhost colon
Yeah.
8081. 8081 is called the port, right? I
Hmm.
can't take over 80 because that's privileged, but it will happily give me 8081 or 8080, which is the default, but I have another
Yeah.
application running on that right now. Um, Going back to where I was. So what we're going to do is uh, install this wonderful thing called the Vue CLI plugin Electron Builder. So boom, nice little thing there. And I'm just
Interesting.
gonna,
By the way, the font in your Google browser is also scaling kind of weirdly, so that might
interesting.
give us some
Okay, we'll have to
clues.
dig into
But
that. Yeah,
I think we have an aspect ratio mismatch somewhere
that could do it.
or the resolution mismatch that's kind of causing a problem.
Okay.
We'll need to compare settings at some point offline.
So I'm gonna go ahead and kill that. Yes. And Electron Builder. So what I did, that Vue CLI thing I was talking about at the beginning, it's the part of the reason it's really nice is it's an extensible tool set. It gives you a really nice predictable application every single time. You get the same file structure, the same sort of base functionality, um, and and then you can expand on that with these plugins. So in this case, someone wrote an Electron plugin that installs the right tools and gives us a really bare bones um, entry script for Electron. So that is going to do this. Two indirect pronouns, that's not very helpful. That is going to install a bunch of npm modules, write a couple of things to my package.json, which is sort of the application descriptor, and then install a couple of extra scripts into the project itself, which, yeah, we're going to go with 9. That's the most recent Electron version. No reason not to. So you can see it's invoking a generator. So that's basically just going to create a couple of extra things
Oh, did
eventually.
you were saying just checking screen resolution, OBS source, and stream res. Yeah, and in this case we have one more complication because actually two more. So I have to do that on my machine here, but then PXLip is capturing a screen which is a particular resolution, sending it through the OBS Ninja WebRTC
Mm-hmm.
stream, and it's landing in my OBS in a web source frame inside my OBS screen. And given that I have it stretched side to side, I'm going to say that I probably screwed up the aspect ratio when I did that.
Well, the other thing we might do is we might switch to the way I was trying my screen the other day, where I can set up a virtual cam probably and pass that to you, where it's a tighter portion of my screen,
Yeah.
so that we're not dealing with the extra wide, or not it'll be a cleaner aspect
Yep.
ratio.
Yeah, we'll
Yeah.
definitely give that a try.
Okay, so back to the application. Hopefully that is at least a little bit legible. I apologize if it's not completely. So you'll see I have the wonderful little color coding that tells me the status of files within the application with respect to my Git repository. So green tells me it's new and it's untracked, so it's never been touched by Git. Git isn't aware of it yet. And this orangey, yellow, amber color tells me that it's been changed. So if I look at here, it's added. I can show you the diff here. So you can see it added its distribution folder. Package lock, we're not going to look at because that's going to be massive. But package.json, it's added some new scripts. Sorry, this diff is a little bit tricky, but you can see on the green, it added some new scripts. It's now telling Electron. So Electron looks at this package.json. This is the script to run to start the application. And then these are the new dependencies that I wanted. And then background.js, this is the brand new one. We won't pull that up that way because that's just messy. So essentially this is the script that starts the Electron application. That's pretty much it, right? So it spins up a new browser window, registers or does some scheme registration, sets up stuff here for this one. This one actually is useful if
It is nice to have a diff built in at OGG. Yes.
Oh yeah. Yeah, the diff editor is, I'm not gonna lie, yeah, the VS Code, the Git integration is probably one of the top 2 or 3 reasons I switched pretty aggressively. So yeah, so basically just walking through, this is sort of this creates the actual application window, and then we handle a bunch of events on the window. So when it starts, when it's ready, and when we want to quit down here. So now if I do this, I can do Electron serve now. So there used to be npm serve, right? That was just basically spinning up a basic dev server with some hot reload tools. This will actually build the Electron app and then load. It's a little bit weird. So it'll build the Electron app, but if you look in the start script, instead of loading the compiled index file, it essentially load the internally running web server, the dev server that's running. So it's a little bit interesting, but
Is that always true for an Electron app? Does it always run an internal server?
No. The reason they do that, and here I can show you. So this block here, so it checks if there's a Webpack dev server. Basically, it means I'm in development mode. It will load the URL and open DevTools. If not, it'll create the protocol and then load the compiled index file. The reason it does this sort of split approach is that if I were to, in development, load the compiled file, I would have to restart the application every single time I changed something.
Gotcha.
This way, everything gets automatically hot reloaded. So I make a change and it immediately reflects in the application itself.
So ODG, I think that was sort of the same thing I was trying to get down to.
Yeah.
So a true Electron app, it does
not
have a Node.js server inside.
It does not.
Yeah.
Ours will, but typically they don't.
That's for a different purpose, not for the app itself. So if it's a browser-based app, there's a server that serves up the code and content,
Hmm.
and the browser renders it. An Electron app, uh, there's neither a well, there's sort of the innards of a browser because the rendering still has to happen,
Yep.
but there is no server. The actual code is that we normally retrieve from the server is baked into the application. Is that
Yep.
a fair way to describe it?
That is an extremely accurate way to describe it. Yep. Yeah, because essentially this is all Electron does is take a stripped down WebKit browser
Mm-hmm.
and wrap it in attach some libraries to it so you can interact with the host OS and leave it up to you to actually provide it some HTML to run. So in this case, this is our HTML, and I can dig in now and say, excuse me. So I can look at my views. We're on home.view right now, and this is a view VUE, um, a view, which always delightful. And all it's really doing is, so I've got a script tag which does some setup, handles any dynamic functionality, and then some HTML up here. So this is all of that. So if I change this message, we'll just say, oh, you'll see I actually auto hot reloaded, and I have the new phrase I put in.
How did the hot reload happen?
So there is,
Oh, because you're in
uh,
an Electron. It's not a browser. It's an Electron app.
mhm.
So it is rescanning.
No, actually, I don't suspect it is. What is happening is part of the part of the Webpack dev server is essentially um, an always-on connection that basically says, "Hey, reload the page."
Got it, got it. Yeah, so it's plumbed to make it's plumbed to make
Yeah,
probably out of band plumbed to make the reloads happen when they need to.
that's exactly it. Yeah, there's an out-of-band communications system that either provides a specific piece that, hey, you should re-render this part, or if it's more complex than that, hey, reload the page. But yeah, that is 100% sort of a side channel.
Yeah. Well, you can sort of see why I wanted to learn this because it is just so different from anything you and I would have done in the heights of our careers. It is just a completely different way of developing things, and
Hmm.
even something that's going to become a very normal looking app, not a web app, is still some of the internal plumbing is just fascinating.
Yeah, no, it's something else. So that sort of do a quick walkthrough because we have a lot of the same stuff in LST. Um, the basically the way that a Vue application tends to work, at least a Vue one with a Vue router, is that I have these views, which basically are pages. A lot of different applications will call these pages. I have a default one, and in the router, I define a path and the name of the component or the component that should be loaded. This one, they're doing some slick stuff, which is definitely good. Just this is dynamically importing the code. So basically, it's late. It's not loaded until I actually need it,
Hmm.
which is which is big for browser-based applications because you're dealing with you want to load as little content as possible on the first page visit, so that it renders as quickly as possible. Um, and then sort of to break up views into sort of logical chunks, you'll see there's a hello world here. Obviously not a real HTML tag. This is a custom tag, which is legal HTML5. I can legally, there's in fact a full spec around custom HTML components and how you define them. And I think GitHub just released some code around basically a framework around writing vanilla JavaScript custom components, which is neat, but you lose out on all our useful functionality. So
ODG is saying I've recently done some courses on front end frameworks and they can take a bit of head scratch. Yeah, head scratching is yeah, that doesn't totally cover it.
and you're welcome, ODG. If you're ever interested, if you ever need a someone who's done this to bounce thoughts off of, I'm happy to help out. You can look me up on Twitter. This is sort of one of the things I do all day long. So, um, but yeah, so this is a base component, right? So this is designed to be reusable. Obviously, a hello world less less reusable than perhaps a button, right? If I want a button that is styled in a particular way and I want to make it so I can use it a bunch of times, a component is really great. Um, so that's the idea behind components, and then we'll kind of leave it off at the store, which isn't set up right now and is a whole nother stream, but this is the Vuex store. I mentioned this. When set up properly, it's a really great way to have a single central state of truth. So the state of my application is stored in one place, and then I can do asynchronous requests, but I never operate directly on the state. I mutate the state. So it's supposed to be atomic operations. There we go. So I make a single atomic mutation of the state. It returns a new state that is the result of that mutation. And then the rest of it
As
gets
opposed to making small incremental changes that are adding up to an atomic that are adding up to the same change, but they would not be atomic because they would execute one at a time.
potentially.
Is that the main reason?
Uh, no, so thinking of sort of the way that and ODG, I see your chat message. I'm going to get to that in just a second. Um, Thinking about the way that you used to store data was a lot of times you would attach data to an HTML element or have it running around in a global object, right? And it was
Oh,
easy
right.
enough
Okay.
to
Yeah.
just change something
Yes.
anywhere, right? So this way I mutate the state. I say, I want you to, hey, Vuex store, perform this mutation with this data. Here's the new data I want you to do something with.
And then everyone else, and every place where you need data, you grab it from the central store.
Exactly. And so the central store updates itself. So if I have a login component, right, and I'm getting the user from the central store, well, initially it might be null, but after they're logged in, it will be an object, right? And so I
Oh
have
yeah.
a
Okay. Okay. I see
a
where you're going. I
user
see where you're
profile.
going. Of
Yeah,
course.
yeah.
Yeah. Yeah. Yeah.
And
That
this
makes
this
sense.
just guarantees a degree of I'm not just arbitrarily changing things from anywhere. Anything can change something, but it's all stored centrally, which is saves brain power in a lot of ways. It just adds a lot of initial overhead, but once it's up and running, it makes life a lot easier. So that is a super bare bones, doesn't really do anything application. I will just point out, so there's the separate public, but literally that's just you don't ever touch any of
Let's
this.
loop back to ODG's comment about
Oh
he
yes,
did
thank you.
React, Angular,
And
Laravel,
Laravel. So
Laravel.
Laravel is literally my day job. Um, uh, Angular and React are essentially the two competitors to Vue. You ask anybody and they'll tell you which one's best, and nobody will ever agree on it. My 2 cents and quick description is Angular tends to be enterprise um, because it gets wrapped up in the .NET words, geez, the .NET environment.
Okay.
So a lot of the Windows tooling, at least before .NET Core, which is a whole nother cup of tea.
And of course, there's a
Um,
bit of politics there too. Yeah.
sure. Well, Angular's it's actually that one's weird because Angular is a Google product.
Yeah.
So it's actually slightly shocking that Microsoft picked it.
I
Probably because
I used Angular
Mhm.
probably before that time. I did a couple of small projects and I just sort of stumbled
Yeah.
into Angular
Well,
as
I think
my framework of choice. But it was probably a couple of versions back, I would guess.
Yeah, I think back in that day, I think I was also using it, and
Yeah.
when we were talking about frameworks at that point.
Hmm.
And so I think I suggested that was back in the Angular 1 days. They completely rewrote Angular in 2, and now onward they've gotten better about not completely breaking everything. React is React and Vue are comparable. React is a little bit becoming React is the hot kid on the block. Basically, everybody wants a React developer. Um, Vue is sorry. Let me go back to React. The problem I find, again, this is all opinion based, so grain of salt. This is just my opinion. Um, what I find is that React takes a lot more, both has a steeper learning curve and requires that you really drink the Kool-Aid. Um, it's trickier to have a sort of integrate React slowly into an application. It's really much easier from a React standpoint to just have a React application, whereas um, Vue is similarly is about on the same par as popularity as far as from in comparison to GitHub stars, basically, which is nothing but a popularity contest. But hey, it's fun. Um, is similar to React. They have a lot of the same concepts. Vue makes it a little bit. Vue has, in my opinion, again, two things that I think made me decide to choose it over React. It's it's a little bit easier to sort of grok. There's no crazy JSX. You're not writing this weird JavaScript in HTML. You write HTML that has some slightly unusual attributes to it, and then you write JavaScript separately, and you just know how they interact. It's also a little bit easier to integrate it into an existing application that may be running, that may be, well, I can speak from experience, an application that was built, using jQuery and old school JavaScript tools. So yeah, to the comment, Angular 2 and beyond, it doesn't require, but it is really tricky not to use TypeScript. Yeah, and learning TypeScript on top of it it's if you don't really just dive into Angular, it's a lot of layers. Um, so that's my spiel on the three main front end frameworks, and they're all inspired by Knockout and Backbone, and I want to say there was one called Batman or Batarang. Um, there were a couple of other ones that were like revelatory in their day and age, and now are quite a little bit more. You wouldn't use them anymore, really. There are still applications out there that do, but it's more unusual. So that's there. You got me off on a nice tangent there. I think we
Well,
were going to talk about OAuth, but
I
perhaps
think maybe
save that
we'll
for next
maybe
week.
we'll push that to next week.
Well, it will
OD,
work out nicely because
yeah,
I'll actually have some demo code that will work.
yeah.
Hopefully.
ODG. I wanted to at least let you know that some of the coding work we're doing on LST on the streaming tool. Pierre Slip is doing a bunch of just the raw coding on his stream, and so I just put that in chat.
You can
And
listen to me
if you happen to be
mumble to
around,
myself and beat my
uh,
head against things.
and again, he's at PXSlip on Twitter. So if you have a chance to follow him there, or if you follow him on Twitch, get the notification of him going live. If you happen to be around when he does that, which tends to be very early in the morning for you guys, for
Yeah,
you.
it would be very, very early for you, so I
But again,
apologize.
there are VODs that you could
Yeah,
catch
I
up on.
and I do record it, and one of these days I'll get it up on a YouTube channel as well,
But
or give it to Prof Cruz and
yeah,
let
but
him put it up as sort of
yeah,
supplemental.
I could create a separate playlist on mine. That'll work.
Yeah.
But there should be two recordings up there now from the first couple of things we did. So,
hmm
the that link gave me not a save page for some reason.
Oh, I see it. It's you're missing a T in your shoutout command.
Oh yeah, how about that? I
There's
will
this
fix
great
that.
there's this great MIT study that I saw ages and ages ago that was we ignore essentially the middle third of any word. It's
Yeah,
the first and the last couple of
I
letters that
wonder
we
when I
read, and
wonder
everything
when
else
I
goes away.
wonder when I broke that. But anyway, sorry about that. If you could just fix, I think you figure out what the URL is supposed to be, and I'll get it fixed for next time. You did notice that I feel a little better now. Thank you, thank you. Uh, so I think what we're going to do here is go ahead and I'm going to switch back to this setup here. I got to get some stuff out of the way. There we go. All right, so I think what we're going to do is wrap it up here. Appreciate ODG. Wonderful have you stop by, and I promise
Always.
when I get next time I get a chance, I'll definitely be in. Um, I'll definitely be back in your stream as well. Um, but so when we don't ignore the middle of the word and put the right T in there, then there should be two VODs on PX Livestream about some of the coding he started, and we intend to keep doing that sort of on and off. Um, and so that's a lot of a lot of sort of the heavy lifting as far as the coding is going to happen there. And so what we're going to do is I haven't decided yet what I'm going to do next for the what I'm going to do next as far as topics. But I'll come up with something. I've got several ideas, but and maybe I'll do something in conjunction with the OAuth stuff. So just to set the stage, and then we'll pick this up next week. One of the first things we have to do when we reach out to grab stuff off of Twitch's API, we have to act on behalf of the users running LSTs, running our application, right? So our application has to reach out to Twitch. Basically says, I want to act on behalf of this user. Twitch will then figure out a way to authenticate the user, do the two-factor stuff and everything else. Eventually get back to us and either say, go away, you're not allowed, or will tell us that you've been granted permission to act on behalf of this
Yeah.
user. Then we have to go out and get kind of a compressed token that we can actually use to authenticate each of the requests we're sending into the API. And the protocol that Twitch uses and many other web data stores use to do that is it's OAuth 2, right? It's
Yeah.
OAuth version 2.
Yeah, and then there are two different flow types, and we can talk through both of
Yeah.
them next week.
Yeah, we'll do that. I might do some. Yeah, so I might do something sort of related to that. But what we'll hopefully be able to do is just have a couple of simple demo applications where we can go through how that's supposed to work, and then obviously it's going to get baked into this much bigger application as one small bit that has to happen there. So again, I appreciate everybody being here.
Ditto.
Hope you have a wonderful rest of whatever your evening brings. And with that, we're going to sign off, and hopefully we'll see everybody next week. Good night, everyone.